A probability tree is another way of representing the possible outcomes and probabilities of an experiment. A probability tree for the experiment throwing a fair coin twice would look as follows. On our first throw, there are two possible outcomes, heads and tails. On our second throw, for each one of those outcomes from the first throw, there is another two possible options, again, heads or tails. Now, because this is a fair coin, all the probabilities of getting each one will be the same. So we see our probabilities here are a half for each possible outcome. What the probability tree gives us is it gives us a journey we can go on to work out the solutions to any given question. Now, to work out the answer to any given journey, we multiply along those branches. So the probability of two heads would be a half the probability of getting ahead on the first throw, multiplied by a half the probability of getting ahead on the second throw, which would give us an answer of a quarter. The same would be said of the probability of getting a head first, then a tail. Also, the probability of getting a tail, then the head, would be a half times a half, giving us a quarter again. And finally, a tail and then a tail would be a half times a half, so a quarter again. Now, all your probabilities at the end of those branches on the tree should add up to 1, which we can see they do in this case. Also, each pair of branches should also add together to give you 1. So if you're required to find the missing fraction on a branch, you can always use the fact that each pair of branches must add together to give you 1. You'll notice from this particular experiment that throwing a fair coin twice is an example of independent events. The last type of probability we need to look at is conditional probability. Now, conditional probability, as the name suggests, is where we have an outcome to an event that is dependent on the outcome of another. And we often see this in experiments where something is not replaced. Let's take a look at an example of where we use both conditional probability and also probability trees. This question here tells us that a bag contains 11 counters. 5 are blue and 6 are red. A counter's taken from the bag. It's colour noted, but it is not replaced. This is done twice, and what they want us to do is construct a probability tree to show the outcomes to this experiment, and then write down the probability of picking a red followed by a blue, and then the probability of picking the same colour on both rounds. So let's draw our probability tree first of all. It tells us the bag contains 11 counters, 5 are blue, 6 are red. So on our first pick, we have two options, blue and red. The probability of getting a blue is 5 over 11, and the probability of red will be 6 over 11. Notice how our branches add up to 1. Now, on the second pick, I still have the options of getting a blue or a red. So for each outcome on the first pick, I now have two outcomes for those. Again, blue and red. But this is where we have to be careful. They tell us the counter is not replaced. So that therefore means, although my fractions were out of 11 here, on the second pick, my fractions are going to be out of 10. Now, if I've picked a blue first, the chance of me picking another blue, well, I've now only got 4 blues left if I've picked one here. So it would be 4 out of 10. If I want to pick a red here, well, if I picked a blue first, it doesn't affect how many reds I've got. So I still have 6 reds. This time it's out of 10. Checking to make sure these add up to 1. How about if I pick a red first? Well, if I pick a red first, it's not going to affect how many blues I've got. So that would still be 5 over 10. And if I pick a red first, well, then I'll have 1 less red from when I pick here. So that would be 5 over 10. So notice how we've constructed our probability tree. Make sure you can see where all those fractions have come from. They're out of 11 to start with and out of 10 on the second pick because we don't replace the counter we've chosen. So all our possible outcomes, therefore, well, this corresponds to the probability of getting a blue and then a blue, so we'll call it BB, and that would be 5/11 times 4/10. Which gives us 20 over 110, which simplifies to 2/11. Blue, then red, that's the probability of BR. 5/11 times 6/10. We could do a little bit of cross-cancelling if we wanted here. 1 and 2. So that will equal 6 over 22, or 3/11. So we've worked out 2 possible outcomes so far, and there's 2 more we need to work out. So let's carry on with those. Probability of getting red and then blue. So we'd say that's the probability of RB. Remember how important it is to keep this order in which the events are happening. So that would be 6 over 11 multiplied by 5 over 10. We could cross cancel again to give us 3 and 5 there, which would leave us with 15 over 55, which simplifies to 3 over 11. And then the last one, red, then red. So the probability of RR, which equals 6/11 times 5/10, the same sum as we just did up here. So we know that gives us an answer of 3/11. Now we can check that we've done it right because all of our probabilities here should add up to 1. 3/11 and 3/11 and 3/11 makes 9/11, and add the 2/11 there gives us a whole. Now, that's only the first part of the question because they asked us to show a probability tree with all of the possible outcomes. So, with the probability drawn, the next part of the question asks us to work out the probability of picking a red followed by a blue. So now we've written out all our possible outcomes, that's easy for us to see. The probability of getting a red and then a blue is this outcome here. So we can say the probability of red and then blue, quite simply, equals 3/11. So there's no calculation to do because we've already done it in the first part. The last part of the question says what's the probability of picking the same colour on both rounds? So this is slightly different because there's actually 2 ways in which that can happen. We could get a blue and then a blue, or we could get a red and then a red. Both of those satisfy that event, getting to the same colour on both rounds. So we have to take that into account. So the probability of getting the same colour equals the probability of blue and blue, that's one way, and the probability of red and red, which is the other way. The probability of getting blue and blue was 2/11. The probability of red and red was 3/11. So the probability of getting the same colour on both rounds is therefore the 2 added together, 5/11. So the probability tree, when it's constructed, is a very useful diagram to help you work out the different possible outcomes because it shows you every possible one in a nice, clear layout. So just be aware that sometimes when you're asked to work out the probability of an event, it can happen in more than one way, and use your tree to check all the different ways in which something can happen.